Hello, today I'm with Graeme Purdy, Chief Executive of Ilika, an AIM-listed company with proprietary platform and technology for accelerating the discovery of new materials. Its particular focus now is on solid-state batteries. Graeme, thanks very much for coming in. Could you just start by giving us a two-minute overview of the business, its history, its business model, and so on?
Yeah. So Ilika started life as a spin-out from the University of Southampton here in the UK. We specialise in using a technology platform that allows us to accelerate the development of new materials, in particular for energy storage, energy conversion, the electronics and aerospace industries. So you can think of us having this horizontal platform that allows us to address different market sectors. We're probably best known for our work in our flagship program in the development of solid-state batteries, and we've invested in that vertical market through designing and building a pilot line, which we also operate in Southampton. And the business model there is that in addition to receiving funding for the development of the technology, which really defines our P&L at the moment, we will license that technology for mass production. And that will use a familiar business model where you receive a license issue fee and then royalties on end products sold. And the idea is that, in particular with those solid-state batteries, is that they can address lots of different markets, lots of different customers who might be interested in integrating that technology into their products.
Over the last year or so, you've really shifted your emphasis away from project work and really focusing more on developing products, particularly in the area of the solid-state batteries. Can you just talk a little bit more about the opportunity there?
It's a very exciting time for the company. You're seeing a business that is moving away from being a company that's focused on high throughput discovery of materials to this focus we've got on solid-state batteries, in particular micro batteries for the Internet of Things. And the Internet of Things is a term that's used quite broadly, but by that I really mean wireless sensor networks, which are designed to pick up information about the surroundings, about an environment, and then transfer that information through to a central control system that optimizes it. So you might find these in smart buildings, where you want to increase the energy efficiency of an air conditioning and heating system. You might find it in a vehicle, which are becoming increasingly instrumented with lots of different sensors. You may also find it in the healthcare environment, and you can imagine the advantages of having a wireless-based system rather than having sensors linked up to a patient. You imagine, for instance, a neonatal baby and wanting to monitor the vital signs of that infant. It's much better if you can do it wirelessly, and that's what our batteries are suitable for.
So could you just talk a little bit about the benefits of Ilika's technology versus the competitors in the field of your battery technology?
Yeah, so we didn't invent solid-state batteries. They were in fact invented by one of the US national labs. Oak Ridge National Lab normally gets credited with that. They came up with a technology that allowed these batteries to function, but only as a single cell. So with a combination of three active layers making up the battery. And we've come up with a slightly different selection of materials and a different process that allows us to stack multiple cells to make a larger capacity device that can be encapsulated in a more efficient manner.
How far away is Ilika from having a product in the market, and what are the key milestones that investors should look for to gauge Ilika's progress in this field?
Yes, well, we invested in a pilot line which was commissioned in 2014, and that's been operational throughout the last calendar year. So we've been optimizing the performance of that pilot line, making prototype batteries, demonstrating that they perform in a manner that's going to be commercially relevant. So just today, actually, we've announced that we're going to have a product launch in the first half of this year. where we'll release product specifications and bundle the know-how and IP so that that can be licensed and manufactured on the bulk scale. And we've also outlined the direction of our roadmap, going from our initial product through to different battery architectures designed for a variety of applications.
So solid-state batteries are the key focus at the moment, but can you tell us a little bit about the developments you've got in other areas, your partners, and the potential for those developments in the longer term?
Yeah, we run a portfolio of different materials development activities. One of the other principal areas in which we're active is aerospace alloys. We run a couple of quite large programs, one of them actually for so-called super alloys, which are used to make the internals in jet engines. In fact, these particular alloys will be used for the turbine discs, which are involved in the expansion of the combustion gases to produce the thrust of the engine. And that's together with Rolls-Royce. And then we run another program which is all about self-healing alloys, which are alloys which, instead of suffering from micro crack propagation into fractures, they have the ability to realign their grain structures so that they actually absorb these micro cracks, and it allows the alloys to perform in high stress cycle environments that you might get, for instance, in an aircraft, say the engine mountings. And that's together with GKN and BAE Systems. And both of those programs are in fact supported by Innovate UK here in the UK.
And then just looking at the discovery platform that you've got, could you tell us a little bit about that, and specifically how it accelerates the development of new materials?
Yes, that's right. The whole concept is about reducing timelines for the development of new materials, because actually materials are ubiquitous, right? You need innovation in materials in order to come up with any new product. And actually there's a pretty strong demand for new materials across a whole range of consumer products. And traditionally it's taken about 10 years to move from the first scientific idea through to a commercial prototype. And actually that's just too long. So organizations are much more interested in trying to come up with things in a 1 to 2 year time frame. And our high-throughput platform allows us to make a systematic array of hundreds of different materials on a single substrate, and then test those systematically to find the materials which are suitable for the end application. And that's where the reduced time to market, enhanced return on investment come from, and hence the commercial demand for our platform.
And then finally, looking at the current balance sheet of the business and the cash levels that you've got, do you feel that your balance sheet is strong enough to take you to profitability?
Yeah, I mean, clearly for a technology company like ours, monitoring our cash on the balance sheet is one of the key criteria that we look at regularly, every month in fact. And you know, the answer to that question depends on the level of revenue generation that we're going to create with our product launches going forward. So our anticipation is that we're well funded for the moment, and we'll continue to monitor the situation.